For A, I'm going to show you two different ways. I'm going to show you the shortcut way first, and then I'm going to show you the way with all the steps that we did before, which was get things to be a single log and then change it to exponential form. Now, in the shortcut way for A, I'm going to rewrite log 6x. I'm going to notice on the right side I've got two logs, and I can combine two logs by multiplying inside. So I'm going to have log, and I'm going to have x plus 6 times x minus 1. Now the shortcut comes in with a simple observation that if log of 6x, and I'll put a box around log of 6x, is equal to log of x plus 6 times x minus 1, does it make sense that what's inside the two black boxes have to be equal? Okay? That's just simple logic. It means that we don't even have to do a complete single log, and we don't have to change to exponential equation. We can go directly from here to say that 6x equals x plus 6 times x minus 1. And then you have to say, in the past, how do I solve equations like this? Well, this is a quadratic on this side, so if I expand it, I'm going to get x squared plus 5x minus 6. And I solve quadratics by making one side equal to 0 and factoring. So x is equal to 3 or x is equal to negative 2. We get two answers here, plugging them back into the original equation. So with 3, we have to check 3 here, here, and here, and make sure that it's positive in each and every case, which it is. So sometimes it's also nice to put a little check mark underneath to show that you know that that one works. When I plug in negative 2, I can see right away, even in the first one, that it doesn't work. I don't even have to check the other ones. You just need to take the log of a negative number once, and then you're done. So you say, Mr. JR, what happens if I forget the shortcut and I'm really stuck on, I know I need to get it a single log, change to exponential form, then solve for x. How would this question look? Well, you still have two logs at this point. If I want to combine them together as a single log, I would need them on the same side of the equation. So you could subtract the log 6x from the other side. And then subtracting a log is the same as dividing with our log laws. And now we have a single logarithm. With this single logarithm, now we can use the most important step and change it to exponential form. What is the base? 10, because it's not written. The exponent is 0. And the answer looks like this. Well, 10 to the 0 is equal to 1. And if we multiply both sides by 6x to get rid of the fraction, 1 times 6x will be 6x. And I'm just going to put dot, dot, dot there because I hope you see that at this point it is exactly the same as what we had when we went to our shortcut. So it takes us an extra couple of steps to do that, but it's not wrong. So if you remember only the steps, and you want to do that every single time, you can always put all the logs on one side of the equation. They'll all be adding and subtracting, so you can combine it to a single log and solve for it from there. For part B, we had 3 equals log 2 x plus 2 plus log 2 of x. So again, some important things that we notice. The bases have to be the same in order for us to use our log laws. These ones both have a log base 2. We're adding logs, so that means we can combine them by multiplying. I'm just going to distribute it right away. X squared plus 2x. And Now that we have a single logarithm, the base is 2, the exponent is 3, x squared plus 2x. It's quadratic, so I'll make one side equal to 0. And factor. X equals -4, x equals 2. Again, I need to go back to my original equation when I'm going to check. If I plug in -4, this one will be extraneous. Plugging in 2 is okay, so this one works. And that is all you need to show for checking. If you wanted to, you could plug it in and actually see that it works. It's not too bad. But this is all you need to show for checking. And the questions you can do for this one are 11 and 13. Yes?